Hello to everyone. In this video, we are going to be solving June 2021 Pure Mathematics with Mechanics question number 2. The question reads, in figure 1 above, ED is a portion of the curve y equal to 8 minus x squared, and ABCD is a rectangle in which BC is equal to 4 centimeters and CD is equal to 5 centimeters. Question A. Show by integration that the coordinates of the centroid of the portion OADE is at that point. 6 marks. Question B. Find the distance of the center of gravity of the whole lamina OBCDE from the side OE. 7 marks. So the topic in interest here is center of gravity. So I would like you guys to try the question and pause the video. When you're done with your solution, you now play the video to see if your solution correlates. Okay, so let's begin with the first part, showing by integration that the coordinates of the centroid of the portion OADE is 9 on 10, is at a point 9 on 10, 86 on 25, which was allocated for 6 marks. So the solution, we begin by displaying the figure that was given to us originally. Now we're given some information. The side BC was 4 centimeters and the side DC was 5 centimeters. Now we're being told that the portion, this portion, which has been represented with an arrow, is 8 minus x squared. Alright, so that's a portion that we are supposed to find the coordinates of the centroid, the portion OADE. So if we let the coordinate of the centroid to be a point G0 having coordinates AB, we can represent it on the diagram. So we have G0, that is the distance B, and that is the distance A. The distance B is the distance from the center of gravity of that portion to the line OX, and the distance A is the distance of the center of gravity of the portion G0 to the line OY, or we can say to the y-axis. Alright, so we are also told that that portion of the curve is y equal to 8 minus x squared. Okay, so by integration, our A, which is the x coordinate of the centroid, is given by this expression, the integral from x1 to x2 of xy is the x divided by the integral from x1 to x2 of y is the x, and the y coordinate is given by this expression as well. Now we're being told that y is equal to 8 minus x squared originally, as we can even see indicated with an arrow on the diagram. Now our x1 and x2, simply we will begin from 0 right up to 2, because that is the range where x lies regarding the portion that we are finding its center of gravity, the coordinates of its center of gravity, otherwise called the coordinates of the centroid. Alright, so we begin with what is common in both expressions, which is their denominators, and their denominators for sure is simply the area of the portion. From calculus, we can say that the area of a curve is the integral of the curve with respect to the regions that they have given. In this case, we are in a region x belonging in the interval 0 right up to 2. We have the equation of our portion, which is, or the equation of our curve, y equal to 8 minus x squared. So the denominator of these two expressions simply gives us the area. So let's begin with that. Remember, x1 is 0 and x2 is 2. So this will simply give us the integral from 0 to 2 of 8 minus x squared dx, because our function y that was given is 8 minus x squared. From there we can split the integral into the integral from 0 to 2 of 8 dx minus integral from 0 to 2 of x squared dx. Now integrating 8x, we have 8x, but we are in the interval from 0 to 2, and the integrating x squared, we have x cubed on 3, we are in the interval 0 to 2. Fitting the upper limit in the first, we have 16 minus the lower limit, which is 0, so you just have 16. Fitting the upper limit in the second, we have 8 on 3, the lower limit is going to give us 0. So simplifying, we see that the area, which is the integral from 0 to 2 of y dx, is simply equal to 40 divided by 3. So that is the area. Now let's move on to the numerator of the expression of the x coordinate, which is a, which is the integral from 0 to 2 of xy dx. So we're giving y to be 8 minus x squared. So xy is simply x into 8 minus x squared. Simplifying, we have xy to be 8x minus x cubed. So integrating xy is equivalent to integrating 8x minus x cubed. So for sure we can split the integrals into these two separate integrals, and then integrating the first part, we have 8x squared on 2, which is equivalent to 4x squared. Integrating the second part, we have x to the power 4 on 4. Remember, we are in an interval 0 to 2. So fitting the upper limit in the first part, we have 16 for sure. In the next part, we have 4. Simplifying, we have 16 minus 4, which is 12. So we see the numerator of the expression of a is simply 12. So from there, we can find the coordinate a, which is the x coordinate of the centroid. So our a is simply the numerator on the denominator, that is the integral from 0 to 2 of xy dx divided by the area. But the integral from 0 to 2 of xy dx, we have seen it as 12, and the area is 40 on 3 as we calculated. So from there, we do a little bit of algebra and we get 9 on 10, which is what was required, the x coordinate. Alright, let's move on to finding the y coordinate, which is b. Since we have the area already, we just begin by finding the integral from 0 to 2 of y squared dx. Now y squared is simply y times y. Simplifying, we have that expression. So the integral from 0 to 2 of y squared dx is the integral from 0 to 2 of 8 minus x squared all squared, which is the integral from 0 to 2 of that expression which we expanded. Now from there, we can split into 3 different integrals, and we have this. This means that integral from 0 to 2 of y squared dx, in the first case we have 64x from 0 to 2. In the next case, we have 16 times x cubed on 3 from 0 to 2, and in the last case we have x to the power 5 on 5 from 0 to 2. That's a fundamental theory of calculus, how to integrate x raised to the power n. You simply have x raised to the power n plus 1 divided by n plus 1, provided n is different from -1. Okay, so this means that we can now try to fit our limits. In the first case, we are going to have 64 times 2. All the lower limits are going to give us 0, because the final function of the integral depends on x. So the lower limits are going to give us 0. In the first case, we have 128. In the next case, we have -16 into 8 on 3. Lastly, we have 32 on 5. So if we simplify this correctly, we are going to have 176 on 15. Now what is b? Our b is simply the y coordinate of the centroid, which is half into this integral, all divided by the area. Now here is our half, now is the integral, the value of the integral, and this is the area. So from there, we try to simplify and we get our response, b equal to 86 on 25. So we can conclude that the center of gravity, or the centroid, has coordinates g, which the y coordinate here, as you can see, is 86 on 25. So in essence, we have proved what was required. Okay, let's move on to the next part of our question, which is asking us to find the distance of the center of gravity of the whole lamina OBCDE from the side OE. Okay, so let's move directly to the solution. So we can let the distance of the center of gravity of the whole lamina OBCD from the side OE to be x bar. Now we can represent it on the diagram. So that's the distance x bar. Remember, it is from the side OE. We can say it is from the y-axis. Okay, so let the mass per unit area of each body, specifically each portion, to be lambda. Now we consider this table where we are going to have the following. We begin with the various portions that exist in the lamina. The first portion is the portion OADE. Here is a portion as represented. The next portion is the portion ABCD, which is our rectangle, as you can see, and the third portion is the portion OBCDE, which is the whole lamina. Now next we move to the areas of these portions. For the first one, we calculated the area already and we had 40 on 3, remember, in the first part of the equation, so we can input that into our table. Next, for the second part, we have the area of a rectangle, which is the length times the width. The length is DC, which is 5 units or 5 centimeters, and the width is BC, which is 4 centimeters. So doing that, we have 20 centimeters squared actually, but we don't actually need the units. They are useless because they are still going to cancel off at the end. So the area of ABCD is 20 square units. So the area of the whole lamina is simply the sum of the areas of its individual portions, because the lamina consists of 2 portions only. You have the portion OADE and the portion ABCD. So the area of OBCD is simply the sum of the areas. So 40 on 3 plus 20 gives 100 divided by 3. Alright, the next part of our table is going to be the weight of each portion. Now what is the weight? It's simply the mass of a portion times the acceleration due to gravity. And what is lambda is the mass divided by the area, because it is the mass per unit area. So from there, we can try to express the weight in terms of our mass per unit area. So if our lambda is mass per unit area, it means our mass is the mass per unit area times the area, which is lambda times A, meaning that our weight is simply mg, which is lambda A times g, as you can see. So from there, we begin with the first portion. The weight of the first portion will simply be lambda times the area, then times g. Here you have lambda, here is the area, and we have acceleration due to gravity. The next, you have lambda times the area is 20 times g, and lastly we have lambda times its own area times g. So we are done with the weight. The next now is the distance of the center of gravity of these individual portions from the side OE, since that is our side of interest. So for the side OADE, we calculated it in the first question, and the distance was A, because the distance, the coordinate of the centroid, the coordinate of the centroid is equivalent to the coordinate of the center of gravity. So here we have a distance of A actually from the side OE, and we found the value of A, and it was 9 on 10. So we can input that into our table. Next, for the rectangle, we can try to find its distance, the distance of its center of gravity from the side OE. Now generally, the distance of the center of gravity of a triangle, of a rectangle or of a square from any of its sides is simply half of that side. So the distance from this side AD of the center of gravity of this rectangle is simply the length, which is DC, divided by 2, which is 5 on 2. But remember, we are finding the distance of the center of gravity of this rectangle from the side OE. So we have this distance as 5 on 2, but what is this remaining distance? It is 2, because it is the distance from O right up to A, which costs 2 units. So in essence, the distance from the center of gravity of the rectangle right up to the side OE is simply 9 on 2, which is 2 plus 5 on 2, for sure 9 on 2. So we can fill that into our table. Lastly, the distance of the center of gravity of OBCDE, the whole lamina from the side OE, was represented as x bar at the beginning of the equation. So from here we are good to go. We now take moments about the side OE. Remember, moment is the force times the perpendicular distance. In this case, our force is simply the weight. Alright, so the whole lamina, the moment of the whole lamina about this side is simply its weight times its perpendicular distance. Remember, this is the perpendicular distance. It makes an angle of 90 degrees with the side OE. So for the whole lamina, we have its weight times its perpendicular distance to be equal to the sum of the moments of its individual portions. The first portion, we have ABCD. The weight is 20 lambda g. The perpendicular distance is 9 on 2, plus the next portion, the weight is 40 on 3 lambda g, and the perpendicular distance is 9 on 10. So from there, we are finding our x bar, which is the distance of the center of gravity of the whole lamina from the side OE. So we can try to express x bar. For sure, lambda g, and lambda g are all going to cancel out because they are equivalent. So from there, we can find the value of x bar, which is 153 on 50. So that was that for the equation, and the second part of the equation yielded 7 marks. It was allocated for 7 marks. The first part was allocated for 6 marks. So in total, the equation was allocated for 13 marks, and the equation was very easy, as you can see. So if you love the video, please like the video, share the video to your friends who are also preparing for the GCE. If you face difficulties in any topic you wish to have a video on, you can comment on the comment section below. Endeavor to also subscribe if you are a new viewer, and turn on all the post notifications so that once a video is popped up, you'll be one of the first persons to receive. Alright, thanks for your time and goodbye.